My name is Mamoon Herzala. I'm a principal cloud architect with Accenture. I'm part of the Google Center of Excellence within Accenture, where our mission is primarily to help clients adopt the Google Cloud and use the right components and architect the right solutions for them. My partner for this presentation apologizes, and he had to be at a client setting, so I will be doing this session alone. So before I go into this session and talk about what we're going to cover, let me just do a quick poll here. How many in the session migrated some of their data or all of their data to Google Cloud or any cloud? Okay, great, about 20 people. And how many of those or others have applied machine learning to that data? Okay, few, 6, 7 of them. Okay, great. Anybody not interested in data? Okay, good. Just checking. Okay, so in today's session, basically what I'm going to cover is talk about some of the data migration challenges that we see in the field. We talk to a lot of customers, and every customer situation is unique, and every customer brings to the table a set of challenges that they may inherit or encounter depending on their situation, and we have seen many of those. So we will be sharing some of those challenges with you and talk about how we can address these type of challenges. So that would be the first part of the presentation. And then we look into more specific GCP type of constructs from data perspective that would help as part of the migration of your data from on-prem type of situations or other cloud providers to Google Cloud Platform. And then we'll look at some of the architectures or best practices that would lead you to get your data into GCP, and then talk briefly about machine learning and some of the use cases for machine learning and what can you do about that, right? And then I'll cap it off with a client example that we have worked with to migrate their existing on-prem Hadoop infrastructure to Google Cloud Platform and talk about some of the aspects of that example and some of the lessons learned that we can share with you, and I'm sure a lot of you probably are thinking or doing some of that work as part of the process. So let's talk about the migration challenges. And before I get into the challenges, anybody knows what that is? Swamp, correct. And the swamp here picture is very expressing to some of the challenges that we're seeing with our customers. I mean, people started looking into Hadoop probably around 2008, 2009, and started migrating some of their existing data to Hadoop. And lots of hype happened when it comes to Hadoop, and a lot of customers ended up with lots of data being migrated to Hadoop. Whether that's needed or not needed, the right solution or not, it doesn't matter. In IT, we look for these type of new technologies, and we start hyping them, and suddenly we think that is the right answer for many of the problems that we have. So a data lake that's supposed to be nice, clear, pristine, that allows you to get and gather the right insights from the data that you have, turns out to be the data swamp because of the fact that the insight that was promised when the data was started to be migrated is not being fulfilled, along with the fact that the performance and the issues around maintenance and the expenses that are associated with data lakes are spiraling out of control, and that basically puts a bucket of water, if you will, cold water on the whole process, and people start becoming less trusting of these type of hype type of technologies, and it impacts the whole organization. So this diagram basically here shows a heart, not necessarily a broken one, so in case you think that it is the case. So it's just a heart, and that heart represents the vitality of your organization. That vitality basically comes from a variety of type of factors. You know, you can look at your infrastructure as one factor of that vitality. You can look at your platforms that are based on that type of infrastructure, and you can look at your applications that are basically being built on top of that. What we're seeing being built today, these type of things, they're great. We can do a great job on these type of systems, but we're seeing missing in the field that the data is the missing link when it comes to these type of systems. We have data, but we don't have the right setup, the right quality. We cannot get the right insights out of that data. So that becomes a challenge, and that basically contributes to the fact that you're not realizing the full potential of the data as part of the process. Now, Some of these challenges that we have when it comes to data, and I think probably all of you would relate to it, data silos. Anybody who has never encountered any type of data silos within their organization, I would love to meet them. Okay. So data silos is a common problem, right? So, and even with Hadoop, when people started building data lakes, the premise was you have a data lake so that you dump all the data is in one single lake. Then when you go and talk to customers, you start looking at, okay, somebody has a Cloudera somewhere, they have MapR somewhere, they have other type of distributions in data lakes. And the question that basically needs to be asked, why is that happening, right? And that's part of the other symptom that we're having because of the fact that the data is growing at significant type of rate. And that significant type of rate basically is forcing you to look at it and say, well, there has to be something good out of it, and I need to store it somewhere. And you start adding and adding and adding, and that becomes a problem in itself, right? And the questions that should have been asked when you start adding this data type of attributes and these data volumes should have been asked in terms of, well, is that the right data that I need to look at? Is it in the right format? Are we going to use that data? Do I need to go and store it in its existing format, or do I need to manipulate it before I go and get it into my data lake, right? These questions in many of our customers where they have these type of situations are not being asked. And that's part of the problem that's being manifested by the fact that I have a data lake, but I'm not fulfilling the promise of that data lake, and can you please come and help us look into what we can do about it, right? So these are type of common challenges that we see with our customers. And many times, when customers start with these type of things, they start looking into a POC. In a POC type of setting, everything is great. You take a simple use case, you create a POC, you run successfully with it, and you say, okay, well, let's continue with that. That's not the right answer, right? A POC is a point-in-time, small snapshot that basically needs to be taken with a grain of salt. When you're done with that POC, there has to be some type of expansion into what does it mean when it goes into production, and what type of extra additional steps or corners that you have cut in order to make the timeline for that POC and achieve that success criteria that you agreed upon before you started that POC, right? Oftentimes, you constrict the scope so that you can do this in 4 weeks, 6 weeks. Everybody feels excited about it, then that continues to be part of the organization, and then that's where the problem starts spiraling up. And then the fact that we have lots and lots of data explosions, and the fact that if you looked at the database vendors 5, 7 years ago, there used to be the typical 4 or 5 vendors, and it was a very easy selection between A and B and C companies. Now, if you look at the diagram, you probably see 50, 60, 70 type of vendors. Everybody is vying for the best in XYZ, different type of structures coming up. Lots of companies are basically having issues and doubts understanding, well, what does it mean to be in this type of format or that type of format, right? So that's part of what's contributing to the mix as well. And the fact that we have lots of skills issues that are hard basically for everybody to keep up with, because the change of the technology is so significant, and I'm sure many of you in this session are suffering from that. You just can't keep up, right? You have to be aware of lots of things in order to keep up with the pace of change. And if that's part of your situation, then it becomes a problem for the organization where you don't have the right skills to make the right decisions. And compound that with the additional type of different complex type of platforms where you need to be in different type of settings with hybrid different platforms, that makes it even harder. So these are some of the challenges that we're seeing in the field. And to look at these challenges and not to do anything about them would be something that would set you up for even failure down the road. Now, what's our approach for data migration in Accenture in general? And before I go and address the data migration approach, let me just talk about 3 factors or reminders to remind ourselves with before we get into the approach. The first one is, remember always the objective. State the objective and try to measure against that objective. That will help you down the road when you assess whether what you have done is correct or wrong, right? If your objective was, I am building this project, whether it's Hadoop infrastructure on-prem or on cloud or machine learning, you name it. my objective is ABC, and here's how I'm going to measure that objective. And here are the metrics that I'm going to measure about. Because if you don't put these type of things, there is no guarantee that when you finish at the end of the day, when the CIO or the CTO comes to you and says, how are we doing on this? Well, we didn't set an objective, therefore everything will go. But if you set certain objectives, you have to report against these type of objectives, and it keeps you honest as well as part of the process. So it's part of the self-governance that you need to instill as part of the organization, and it starts with that. And as part of the process, remember that we want to derive value out of data to enable ubiquitous in type of intelligence, what we call in Accenture, right? Different companies call it different things, but we want to have that type of intelligence insights that we want to bring to the table, and we want to make sure that we are bound by these type of objectives and goals as part of the process. And as you go and try to accomplish that type of objective, which is a very noble one, there are different type of companies. We know that different type of customers have different type of settings, and what's appropriate for a small business may not be appropriate for a large enterprise, right? So you would have to take that with, my company, 5 people company, 10 people, or 100, or 1,000, or 20,000 with 2,000 people in IT, right? Different things means different skills mean different things, how you can accomplish or go about what type of approach that you want to take when it comes to data migration. And if you were to look at it, the way we look at it at Accenture, we have a maturity scale, if you will, where it's incremental. So customers look at it and start looking at, okay, well, one of the first things that we do, we look at data storage type of migrating to the cloud. That's one of the easiest things that will get your feet wet as part of the process, where you can start migrating some of these type of things to the cloud. As you start getting them into the cloud, you start looking at your applications. What can I do within my application type of domain so that I can leverage this data that I have just migrated to the cloud? As you start looking into that, you start looking for ways to optimize your data architecture for new different type of applications that you basically say, well, you know what, I no longer like the fact that we're bound by these type of legacy constraints that we had earlier. So we're trying to re-architect systems that leverage everything on the cloud. That's what we call born on the cloud type of things, or native type of cloud applications. And as you start gaining the lessons learned and the experience, our objective is at the end of the day, and it's an incremental one, just let me re-emphasize on that, is to get to what we call the data intelligence on the cloud, right? Whether that means machine learning, AI, or whatever it is, you name it, it doesn't matter, right? I want to extract that insight from the cloud so that I have the right consumers, I have the right insights at my fingertip, and that would allow me to impact the business so that I can operate using new different business models, new revenue streams, because I'm able to consider new patterns that my data is allowing me to do, and that intelligence is giving me insight such that I can go and start marketing to a different segment that I completely ignored before using that type of intelligence or before using machine learning, right? New different clusters of customers are coming up, a new way of discovering new medicines or interactions between different medical type of components, right? So all of these type of things, the objective is to get to that data supply chain on the cloud so that we re-architect our on-prem type of data so that it's modernized and extended to the cloud, and at the end of the day, I can create these type of services that would allow me to go there. And as part of that process, basically, you have to go and look at, well, what can I do differently to get to that level of maturity, right? So it all starts with capturing. So we have different type of formats, different type of data that's coming along the way from different type of sources. Is your existing type of practices capable of capturing that type of data? And most likely the answer is not. So you have to go and look at that and assess what's needed in order to get there. Once you capture, curate, put that with like 10 underlines there, because that's one of the premises that would guarantee you that you will not fall into that data swamp type of practice. It's one of them, but it's a key one. When you start curating your data, that means basically Not a single person will come and say, okay, well, just get that file and dump it into the data lake. There would have to be lots of checks and balances that basically would say, okay, why are you doing that? What type of data that we're getting into? What type of data profiling that needs to be applied? What type of metadata, et cetera, that needs to get there, right? And once you do that, I can enable the consumption of that data in my type of organization, and then I enable additional things related to manage and govern, because once you get it there, you need to manage it, you need to govern it, and that becomes a continuous cycle. And then as new things happen, you need to evolve. You don't just do it once and say, okay, well, I'm done with it, because there is always a new data format that would come up that may expedite things, that may do 10x load factor for your data. That could be something that you want to look into, right? And then how you can operate that data and get it into the new ways of doing things, whether that's social, mobile, IoT, whatever it is that we hear about all this time as part of the evolving of technology that we see on a daily basis. Now, this slide, it's not intended to scare you, especially for those who are on the small and medium size. This slide is really here to show the level of sophistication and complexity that is required in order to get to the right data practices. Why is that? Because it's not an Accenture invention if you look at it. I mean, it starts all the way from vision and mission and creating the right data strategy for your organization, all the way down to what type of measurements, and then the cross-cutting concerns around governance management. If you are an SI sitting in this room, you come and say, well, we have something similar, right? And I'm sure a lot of you are doing something similar to that. And I raise it here just because it's needed. Whether you implement 100% of that, or you implement 50% of that, or whatever percentage that you think is appropriate for your business, remember the 3 principles we talked about earlier. I have an objective, I have a different way to approach it, whether I'm small and medium versus a large organization. And similarly, I look at this type of methodology and say, okay, well, what do I need to take out of that? And that becomes a decision point for your organization, so that you look at it and say, okay, for my organization, I'm going to do these type of activities, or I'm going to do some of them, and I'm skipping X, Y, and Z, and you document that. And there should be a good, valid reason why aren't you doing that, right? So that becomes an important thing, so that you are aware, at least you give it a thought, okay, for my type of situation, I don't need that. And here is looking at it from agnostic type of perspective. You start looking at your data sources, data staging, data ingestion, how you are going to curate the data. All of these type of things are decision points. What are you doing about that type of real-time ingestion for this type of data formats? Are you having to deal with that type of setup, or is that something that's not necessary? And if you do have this type of thing and you're not doing anything about it, are you losing any type of benefits as a business from not paying enough attention to that type of data? So let me switch gears to data migration in GCP, and I think that's where the majority of you are coming here as part of the process. So we covered the methodology, and the key point from methodology is the fact that it's not a trivial type of endeavor. If you talk to somebody, and I have talked to many customers in the past, where they come to us, you know what, we'll just move that data from here to Google Cloud in 10 minutes or 1 hour. That's it, right? That is the wrong answer. Yes, we can do that, but is that what we want? The answer is no, right? And for the previous reasons, if that has planted the seed of doubt, when somebody talks to you about this type of proposition, I think you need to be asking these type of questions when somebody comes and says it's an hour type of a job, or 2 hours, or 3 days, or whatever it is, right? Because the objective is not to get the data to the cloud. The objective is, what can I do with that data? What type of insight, what type of governance that needs to be there, right? So let's keep that in mind as we look into data migration to GCP, because I'm going to be claiming that it's going to take 10 minutes, right? Because yes, it does, but keep that in mind. Okay, so the first question when it comes to data to GCP is the question around speed of network and how much data do you have as part of the process, right? So if you're trying to migrate 10 terabytes or 100 terabytes of data, and you're having a network speed of 100 megabits per second. You can see that for 10 terabytes, I'm going to take 12 days. For 10 megabits, I'm going to take 124 days. If you happen to be on the lucky side of 1 gigabyte or 10 gigabyte or 100 even, it's going to take much less. So the question will basically you need to ask, am I going to do this on a physical type of manner versus online? And you'll use this chart basically to help you to decide. If you happen to be on this lower corner here, most likely you are going to use a physical type of approach to move your data from whatever location into Google Cloud. Okay? Next question that comes to be asked, and it's an important question, is if you were to look at the Google data constructs that we have out of GCP, if you look at it for the first time, it could be overwhelming, right? So the next question that basically you need to ask is, what type of data I'm trying to migrate? And if you start from top, you can look at it from two different classifications. Either it's a structured data or unstructured data. If it's unstructured data, it's pretty much easy. If I don't have a need for mobile SDKs, Google Cloud Storage most likely, an object type of storage, will be the answer to you, right? If you were to say, okay, it's more of a structured data, then we look at it from OLTP versus OLAP type of classification. If it has more of a transactional load, we have a decision point that we need to make. If it has more of analytics type of load, we have the big table versus BigQuery, and the primary difference is in the type of latency that you get in terms of big table versus BigQuery. If it's on the transactional workload, then you look at it and say, do I have a preference for SQL type of interfaces versus NoSQL? And that's where you look at it and say, okay, well, for SQL type, we have the Cloud SQL with MySQL and Postgres as the two flavors that you get out of the box in GCP, plus Cloud Data Spanner for the horizontal scalability and real-time type of applications that require that level of performance. And for those who wants to do the NoSQL document type of store, you have Cloud Data Store and Firebase Real-Time DB, especially for needing mobile SDKs. You can use that, but doesn't necessarily mean that you cannot use Cloud Data Store with mobile devices. It just gives you additional capabilities when it comes notifications and these type of things that makes life a little bit easier for you. The third question that you need to ask is, okay, I figured out it's going to be physical or online. I figured out what type of construct that I need to get. Then the third question is, how can I get my data into GCP, right? And that's what this slide is trying to address here. And look at it from in terms of distance to GCP at the bottom, the x-axis, and the y-axis is the amount of data. So from x-axis perspective, you look at it, if you are in GCS or Google Cloud Storage, the data is already there on Google Cloud. It could be in a different region. You want to shift it to another region. Or it could be in S3 buckets, Amazon or something else. Or it could be in a colo type of facility with good type of connectivity, or on-prem with that type of connectivity, or it could be somewhere on-prem with low bandwidth or no bandwidth at all. You're at the sea, right? So what do you do with these type of situations? So if you were to look at it from that perspective, we have the Google Transfer Service. That's part of the Google console, right? So you can go to storage, and you can set up the Google Transfer Service. You can do it run once, run daily. So you can think of it, if you want to, as a cron job, that you can do it to back up continuously as part of the process. And you can, there is no limit on the amount of data that you can do with the Google Transfer Service. It can do retries as well, and it can help you with that perspective. If you were to look at the colo type of situation or on-prem with good connectivity, then one of the primary answers we have is GSUtil. You get GSUtil as part of the Cloud SDK. You can install it, and you can start GSUtil CP, and you can copy from bucket to bucket, or you can copy from one location to another, and it has the ability to chunk the file into multiple ones and aggregates them on the end, and it does all of that for you. It has retries, can do all of that. If you don't like GSUtil, you have different vendors that you can use also. If you want an approach that a vendor could come in and do it for you, you can use Bitspeed, Aspera, Trivla, and there are other vendors as well. I put the link later where you can go and look at the latest and greatest. Then the third option, if you don't have enough bandwidth and or no bandwidth at all, so if the data size is less than 100 terabytes, usually you would get into the Iron Mountain in North America, and there's Prime Focus Technologies in EMEA and Asia Pac, and you could still use the Google Transfer Appliance, right? So these are things that you can do. If the data size goes above 100 terabytes, you can have the Google Transfer Appliance, where they ship that appliance to you, you put the data, and you ship it back to Google, and they'll import it back to you, the right project, to the right buckets in Google Cloud Storage. Right? And the same thing for Zardara. Zardara also have an option for data hydration, where it ships two devices. One, you can put the data and ship it back. The other one, you can keep it on-prem, where it starts syncing the data for Delta type of changes down the road. Now, this is pretty much for the first entry into Google Cloud practice, right? Google Cloud Storage. Now, you may have structured data. And structured data is also, you can move it from different type of sources to different type of sinks. And primarily for structured data, if you looked at the previous diagram, we have two databases or two constructs. One is the Cloud SQL with MySQL and Postgres, and the other one is Spanner. You can, if you want to, use the old traditional ways of doing data dumps, dumps from SQL1 to SQL2, and you can do that. But lots of customers don't want to do that. They want to migrate or move tons of data, and they'd rather use a partner. You can do that too. And you can do the same thing for BigQuery. It's also a partner play where you can have different type of sources coming from databases, SaaS, data warehouses, or B2B EDI type of stuff. And you have all these partners that are basically having their different type of solutions catering to migrating that data to BigQuery. If you have, and also we have this that was announced last year, that you can migrate and the ability to ingest data from DoubleClick, the digital marketing type of platform from Google, along with AdWords and YouTube. And you have additional sources that are listed under that link for Facebook, Twitter, et cetera, that can be part of that process of migrating data to BigQuery. Now, there are other people who are on the other end of the spectrum where they have the right engineering or whatever it is. They would like to tinker with their hands. And Google gives you the ability to do that. So you can use GSUtil tool to do that if you want to. So you can get the data through GSUtil to a Google Cloud Storage, and then you can use either the BQ command if you want to, or you can use the web UI, or you can use BigQuery APIs to get the data into BigQuery. It's just a more type of a more manual approach that you would have to be kind of doing that. Just something to keep in mind, BQ tool, when you get the data to BigQuery, you're basically making a fundamental assumption you're not enriching the data, or there's very minimal type of changes that you need to do on the data, right? The moment you start saying, I want to do multiple joins, I want to do some data enrichment, then that's where data flow comes into the picture, and I'll talk about that shortly. But that basically is what this fundamental premise here. You can use user-defined functions in BigQuery to do certain manipulations, but still, it's limited in terms of the enrichment that you can do on the data set before moving it to BigQuery. Now, this slide, I don't recommend that you show that slide to your customers or anybody outside of being a techie, because it's overwhelming, to be honest with you. If you to show that, hey, by the way, I'm going here to sell you something on Google, and here's what Google offers out of the table. It's complete opposite purpose. You know, I should show it here because I want to show you that there are tons of capabilities, and the objective is to be more prescriptive when you talk to your customers, right? Yes, it's great that we have a lot of constructs around capture, curate, discover, manage, and consume and manage, but you as a potential partner or customer, you need to figure out what is the right use case for you, what is the right construct for you, and then try to figure out, okay, here's what I need to do. It's maybe cloud data prep, cloud data flow, cloud pops up, and BigQuery, right? So these are the ones that I'm interested in. The rest is great to have. I can look into it later, but show that to your customers from the get-go could be counterproductive. Now, there are customers who basically say, you know what, I don't like this whole thing about the migration, so I want a white glove type of service, and that's where Accenture comes in, right? With every vendor, you looked at the vendors in the previous slides, there are so many of them. And with so many of them, basically that gives you the freedom to choose, but also gives you the potential that you may shoot yourself in the foot, because you may be picking the wrong construct, you may be picking the wrong cloud platform, you may be picking the wrong tool. And Accenture basically what allows you to do in that white glove type of approach with what we call the smart data movement, you just tell us we want to move from point A to point B, and you don't worry about the rest. We go and procure these type of licenses for the right tool for you, and we do the migration, and all you have to do is just let us see where the data is coming from and where it needs to go to, and that's it. We take care of that, right? So that's part of the construct, and we also have capabilities around different type of elements when it comes to capture, curate, discover, consume, and manage, right? So there are different capabilities there. I'm not going to go into them, but just be aware that they are available to you. Here is the SDM type of approach under the covers. Basically, we cater to different type of cloud providers. GCP happens to be one of them. Under the cover, the right tools would be procured, licenses managed for you, and you get to that. So you're pretty much agnostic. You don't care about whether it's tool A, tool B, that vendor goes out of business tomorrow, or are they still in business? It doesn't matter, right? We just give you the guarantee that they will be there. You're not locked into any specific vendor, and that does the job for you. So let's talk about path to machine learning and AI. So machine learning and the use cases, I doubt there has been any session today where machine learning probably was not mentioned somewhere in that session, right? We are at that level of hype cycle that, and don't get me wrong, I love machine learning. I mean, I think it's a wonderful technology, right? But it's with everything else, like we have done in IT, when we start looking at something and overhype it, and we start looking it's the answer to every question that we have, that's where the problems start arising, right? And I think we are at that level where everybody says, and comes talk to us, oh, I want to apply machine learning to my XYZ. And I bet you that many of those type of customers, they don't have the right awareness on what is meant by machine learning, and if that is the right set of tools or processes that would allow them to address the problem. But as you can see, there are lots of use cases that are listed here across different type of industries that basically, everybody is looking at saying, okay, well, predictive maintenance or condition monitoring, right? We've done that with predictive model in the past, right? Things were okay, probably 80%, 90% accuracy. Now with machine learning, additional constructs that are happening, you can get to higher levels of accuracy, right? So Google basically says we have elements of machine learning in every product that we have. That's great, that's Google, right? But the majority of customers out there, they're not Google. So you have to be very careful when it comes to machine learning and say, okay, well, am I addressing the right set of questions? Am I having the right use cases as part of machine learning? And is the right thing for me to do as part of the organization? And if you look at the transforming data into actions, Google provides different type of constants when it comes from data ingestion all the way down to advanced analytics and machine learning and abilities to do that, right? So, and these type of steps would be required. If you attended the Miles Ward session, the first thing that we do in machine learning, I have to get the data into GCP, right? Somewhere, I need to get the data and then start building applications, and that generates additional data. Then you start applying machine learning, right? So these are key, and that's part of what the ecosystem that Google provides in order to give you that ability to ingest the data all the way up to creating that advanced analytics and intelligence and apply machine learning onto it. And if you are interested in what type of constructs that you are looking into, here's the diagram. Again, I wouldn't go and talk to my customer and say, okay, here, look how Google is great and all of that, because that basically tells complexity. So we want to be more prescriptive as part of the process and figure out what type of things that we need to do in order to get to that level of complexity. So if you were to get the data into GCP, right? Here are some of the things that we see as big data reference architecture, right? So typical components, these are the typical suspects. I have two types of workloads. One could be potential streaming workload. The other one is a batch workload. And the objective is to get it somewhere into BigQuery or Bigtable or whatever it is, right? And usually we look into it and say, okay, well, for pub sub type of streaming, We have a Cloud PubSub that we want to incorporate as part of the architecture. And then I could take that stream and let it feed through data flow, because I want to do certain manipulations. I could do certain enrichments on it, whatever I want to do. And then I can have a resting place in BigQuery. So that would be one path to look into it. You can take a batch load. You can put that batch load in Google Cloud Storage, the GCS component, right? And you can take that batch load and say, OK, well, I want to apply certain enrichments on it as part of the process. And then for this particular load, the data could be more appropriate for being stored as part of Google Bigtable, because I am very concerned about latency, and Bigtable gives you that type of access to it. Or you can say, I would like to apply certain data proc type of capabilities, manipulations, and then store the data in Cloud Bigtable. You still have the option, if you wanted to store data in Cloud Data Proc, right? You can use data proc HDFS on SSD or persistent disks, but that's not necessarily a good approach, because it's more expensive to store that data in data proc, right? The best practice is to have the data store in GCS and allow data proc to run clusters that would basically figure out what would be the right destination for that data. So this is pretty much the end-to-end way of looking at a big data reference architecture, by allowing you to get a streaming load or a batch workload to get the data into GCP. And then you have, on the far right end, is the ability for any type of data, further data exploration, machine learning type of activities, analytics, dashboards, whatever it is that you can start looking and applying on these type of data sets that you have stored as part of BigQuery. Now, let's dissect that piece by piece and look at it and say, well, you know what? I have a streaming load. I just want to get it directly to BigQuery. Can I do that? The answer is yes. You can. There's nothing that says you can't, with the assumption that you're not manipulating the data. We talked about that earlier, right? So you can get a streaming workload or a batch workload and put it directly into BigQuery, and you can do simple manipulations on the BQ command, and data will get into BigQuery. If you want to go and say, OK, well, I have a batch workload. This is I would like to go and put that into my Google Cloud Storage. I would like to do some type of enrichment on that type of workload. And then I want to batch that pipeline into BigQuery. And that's also another option that's available to you. And then this one is, I have an on-prem type of data that I parked on-prem through an ETL job. Now I need to move it. It's a relational, so I need to move it to Cloud SQL into GCP, and then I take that data from Cloud SQL, and I can run it through my data pipeline, again, against Cloud Data Flow, do some additional enrichments, joins, or whatever it is that you want to do with it, and then feed it into BigQuery. That's also a pattern that we see out there. Or you can have a fan-in, fan-out type of multiple streaming type of clients that you want to get the data. And as part of getting that data, you want to do different type of processing for that data. And you have different instances of BigQuery where you have instance A of BigQuery and instance B of BigQuery. And you can have the right job being streamed to the right channel that becomes the ending resting place for BigQuery. And you can have also additional type of manipulations where you can stream and compute before you publish. So I stream my data from a financial type of company or organization, and as part of the process, the data gets into Cloud PubSub, and then I do certain manipulations on the data, certain enrichments, calculations, and then I add additional type of windowing or do time type of series calculations, and then I calculate certain correlations and then feed that again to a Cloud PubSub where I have multiple subscribers, where I'm trying to figure out how the stock market is going to do or how certain stocks are going to behave under certain type of situation or conditions, and I can feed that into a trading system where there could be people who are waiting or acting on these type of intelligence. Or I could feed that back into BigQuery, where I can apply certain dashboarding, analytics, machine learning, whatever it is that I want to do, and I can start exploring with Cloud Data Lab as part of the process. So what this is trying to show you The suspects that you have seen, they're very common, right? So we talk about PubSub, Dataflow, BigQuery, Bigtable, and Data Lab as part of the top components that are usually involved, and GCS, obviously, right? These are the primary ones that are involved as part of the process of getting data into GCP. And here's an example. Interesting. OK, so here's an example where it basically shows I have an existing data lake that's installed on-prem. And as part of that process, I have different type of data sources. And I need to feed that data into a Google type. OK, so I have different type of constructs that I want to incorporate. So I have the GCS connector, where basically I can push the data directly to GCS. Because GCS, it's Hadoop compliant type of file storage system. So using that GCS connector, I can use the push model, where I can push the data directly to GCS, or I can aggregate the data, do some type of enrichment on it, and I can use a partner, happens to be Informatica or anything, it doesn't matter. And I can use that to push the data to GCP, and then I can feed that into my pipeline of Cloud Data Flow or Cloud Data Prep, which also allows you to do some additional data profiling as part of the process. And then you can have the option to move the data into cleansed data as part of the storage. And this is basically ingesting into a data lake. And as I mentioned earlier, as part of the data lake, we try to avoid storing stuff in Dataproc. So the preferred method is to use the cheaper storage of GCS. And if your workload happens to be more appropriate for Bigtable, sure, why not? You can do that. And in many instances, you will see that people will go against BigQuery to store the data and use Dataproc ephemeral clusters, basically, to run certain jobs and store the data in the right resting location. And you can apply the visualization on that as part of the process. And this gets us to the machine learning lifecycle, right? So the machine learning lifecycle, if you attended Miles' Ward, you probably have seen this diagram. I did not have it, and I recreated it for this session. So I'll give credit to that. So this basically defines the first thing that you need to do as part of any machine type of learning is to look at the use cases. And I alluded to that earlier in the session. That becomes a really important type of factor to make sure that you are addressing the right ones and defining the success criteria that you want to do. Then we get into data exploration. Basically, I want to do exploratory data analysis, and you can use any type of clustering type of mechanisms. I'm trying to reduce the amount of parameters that I want to build the model from. And I can go and select what type of machine learning algorithm, and I can do later further feature engineering, which basically looks into additional type of criteria and selecting the right parameters for the right model. And you build your first iteration of the machine learning model. And you iterate on that with, kind of building your minimum viable type of model, right? And once you do that, you basically look at it and say, OK, well, are there things that we can change or improve as part of the process? And then you start presenting results that, yeah, OK, well, you told us that we can challenge the current supply chain model that you have in order to give you better accuracy and cheaper way to get these data parts coming to the US through different vendors and routes, and here's the model who would allow us to do that, right? So let's look at these results and see if there is any value into them, or if the older model is a better type of performing model. And then you start planning for deployment in production, and that's where you start getting into interesting type of setups, right? So what type of production, what type of clusters, what type of data ingestion, how busy are the machines going to be? Are they going to be busy all the time? Are you going to stream the data? Is it batch, et cetera? Are you going to run this at the same time while other data is coming? So all these are type of questions. And usually what we do, we start with a POC, a simple POC that doesn't factor any of this into it. And people think that once they've done the POC, a lot of the legwork has been done, and you get into the previous pattern we talked about with data lakes. It's not. There's a lot of consideration that needs to be taken from 7 through 10 to make sure that we have the right models, we monitor them, they are the right ones that are the most efficient, and sometimes there could be some performance issues that could rise in the future. So what do you do about those? Do you go and rebuild the model and you repeat the cycle, right? So the whole process is iterative and lots of complexities in the details here. It's not just building a POC in 6 weeks and we're done with that. So, and you've seen this probably before if you've been to many of the sessions. You can use your own pre-built, ready-to-use models. There is no point for you to go and create a model that can go and recognize objects, right? We're talking to different companies right now to build solutions around these things. I can look at satellite images, I can look at third-party data, weather data, and look at natural language processing, translate APIs to come up with a solution that would give them a better score when it comes to underwriting processes for insurance, right? So these are things that you can put together as part of the process. You can build a model that takes elements of these type of factors and incorporate that into a model that can give you a better result than what you may be having today. And you can use your own data to train these models. You feel free to build your own models using TensorFlow, and feel free to upload them to Google Cloud, let them run in the cloud, and see what type of results that you can get out of that, and empower your business to be the right business. I have 1 minute left. I want to spend on this client example. I talked mostly about what this thing is all about, but this is a customer. The pattern that we're seeing, they were running Cloudera on-prem, using and spending a lot of money, really. That was the primary driver for them. They were basically spending about $20K per month on their Cloudera type of setup. And they came to us and said, well, we would like to move that to GCP, right? So if you look at the architecture, this is what they have as part of this. So they have Cloudera running on GCP in VMs type of formats. And the solution was basically to get them to the right setup using Dataproc and ephemeral clusters and using Google Cloud Storage as part of the process. The previous session I was here in the last 10, 15 minutes, the gentleman was citing different statistics about moving the Hadoop infrastructures into Dataproc. He was citing 70% savings on hardware, 80% or more on software. We saved this company from 20,000 down to 4,000 per month, and it's about 80% savings. So I'm glad we have the consistency in these type of settings as part of the savings that you can get from migrating these existing Hadoop workloads from on-prem or using VMs on GCP. Sometimes people think I'm using VM on GCP for Cloudera, I'm still on the cloud. No, you're not. Well, you are, but it's not the most efficient way to do it, right? There are better ways to do it, and this is one of those things that you can use as part of that process.